Hi everyone, in this video we are going to learn the fundamental theorem of arithmetic. Let's consider a number like 30 for example. Okay, now we are going to express 30 as a product of prime factors. So you know that 30 can be written as 30 is equal to 2 times 15. Okay, and this can be further broken down into 2 into 3 into 5. So now you see that all these numbers are prime numbers. So 30 can be written as a product of prime factors in this way. Let's move on to the fundamental theorem of arithmetic. So the fundamental theorem of arithmetic says that every composite number can be expressed or factorized as a product of prime numbers. And this factorization is unique apart from the order in which the prime factors occur. So as we saw in the previous example, the composite number like 30 can be expressed as a product of prime factors 2 into 3 into 5, and the important part of this theorem is that this factorization is unique. So apart from this 2 into 3 into 5, there is no other way in which you can express 30 as a product of prime factors apart from the order in which the prime factors occur. So instead of writing 2 into 3 into 5, you might as well write 2 into 5 into 3 or 3 into 5 into 2 or some other order. So if you consider, if you ignore the order in which the prime factors are written, you'll see that the factorization is unique. And this theorem can also be stated as the prime factorization of a natural number is unique except for the order of its factors. Now let's consider a composite number x. So as we saw before, we can write x as the product of prime factors. So suppose we have written x as a product of prime factors p1, p2, etc. up to pn, and p1, p2 all are prime numbers. And if we have this additional condition, that is, we are arranging the prime factors in ascending order. So p1 is less than or equal to p2 is less than or equal to etc. up to pn. So all these numbers p1, p2 up to pn are arranged in ascending order. So if we do that, then we can confidently say that the way the number is factorized is unique. So once you arrange the prime factors in ascending order, then there is only one way you can write the composite number as a product of prime numbers. Alright, now let's move on to finding LCM and HCF by prime factorization. We have learned how to find the LCM and HCF by prime factorization in smaller classes without realizing that the method is based on the fundamental theorem of arithmetic. Let's take an example. Let's say two numbers 6 and 20. So we need to find the LCM and the HCF of these two numbers. Going back to what we did in earlier classes, the first step is to prime factorize each of these numbers. You can write 6 as 2 times 3. So 2 times 3 is the same as 2 raised to 1 into 3 raised to 1. And 20 can be written as 20 is 4 times 5. 4 is 2 squared. 2 squared times 5. To find the HCF, we first take all the factors that are common. So if you look at this and this, you'll find that the only common factor is 2. Okay, and we see that the smallest power of 2 among these two is 2 raised to 1. So it's 2 raised to 1 here and 2 raised to 2 here. So the smallest power is 2 raised to 1. So that's the number you have to take. So 2 raised to 1 is the HCF of 6 and 20. So you can write the rule for finding the HCF as product of smallest power of each common prime factor in the numbers. So you saw that for 6 and 20, the only common prime factor was 2, and you take the smallest power of 2. So you take 2 raised to 1, and that is the HCF. Now let's see how to find LCM. Okay, so for LCM, we need to look at all the factors which are present in either of the numbers. So it doesn't have to be a common factor. So here we have a 2, okay, which is also present here. So you just write 2 here for the time being. And you need to take the highest power. So 2 is 2 raised to 1 here and 2 raised to 2 here. So the highest power is 2 raised to 2. Now what is the next factor? 3. So 3 is a factor here. So remember that it doesn't have to be a common factor. So 3 is here and the highest power is 3 raised to 1. And then we have a 5 here. So that's 5 raised to 1. So we need to multiply these 3 to find the LCM. And also note that we have already considered this 2. So you needn't consider that again. So this works out to 4 into 3 into 5, which is 60. So we find that the HCF of 6 and 20 is 2 and the LCM is 60. So as we just saw, the rule for finding LCM is to find the product of the greatest power of each prime factor involved in the numbers. Now there's another interesting property here. If you look at these LCM and HCF values, if you multiply the HCF and the LCM, you get 2 into 60, which is 120. Now if you multiply the numbers A and B, so if you multiply 6 and 20, you get 120 again. Okay, so that's the property that is stated here. For any two positive integers A and B, the product of HCF and LCM is equal to the product of the numbers themselves. Okay, and here's a brief note on the man who first proved the fundamental theorem of arithmetic.